Hello everyone. So welcome again. So I hope that you have done the previous sessions. Okay, using for loop I've done it. Today we are going to do while loop. So we are going to understand when I have to use a while loop, how to use a while loop. Okay. So when I talk about a while loop, okay, in generally when I talk about any loop here, okay, a loop will have initialization, condition, statement, and updation. These four are the important factors of a loop. If you don't have one also, the loop will not function. The loop will not what function. In the for loop, it was hidden. Okay, what was hidden? The updation was hidden. Initialization was there and the ending was there. What was not there, updation was not there, which I am going to show you right now. Okay, but remember, whenever you write a while loop, always ask a question: what is my initialization, what is my condition, what is my statement, what is my updation? This four has to be there. Okay, now when I talk about a loop here, okay, so when you wrote, right, let's say in this case I want to print 1 to 10. 1 to what? 10. I want to print. So what do I write in a for loop? I write for I in range of 1 to 10, and then I print the I. Okay, it will print 1 to 10, but it will print 1 to 9 only because 10 is exclusive, right? 1 to 9. If you want to print 10, I need to put 11 here, correct? Now, in this, what is my initialization? Yeah, this is my initialization. The loop is going to run up to 10. That is my condition. And this is my statement. But where is my updation? Yeah, it is there. By default, it increases by 1. Default increases by 1. If you want to print 1357, then my updation will be 2. That's it. My updation will be what? 2. How do I write this? The same thing I'm going to write it in a while loop. How do I write it? If you want to write in a while loop, I'm going to write like this. My initialization is outside. The condition is inside the while. What is the condition? I is less than or equal to 10. This is a header. Below the header, you will write the body. In the body, you will write the statement. What is the statement? I. Then what we said? We have an initialization. We have a condition. We have a statement. We have updation. Updation has to be what? I is equal to what? I plus 1. Every time we increase I by 1. Updation has to be there. Okay. So how it works for me? I is 1. 1 is less than or equal to 10. Print 1. I became 2. 2 is less than or equal to 10. Print 2. 3. 3 is less than or equal to 10. 4. 4 is less than or equal to 10, 5. 5 is less than or equal to 10, 6. 6 is less than or equal to 10, true. 7 is less than or equal to 10, yes. 8. 8 is less than or equal to 10, true. I print 8. 9. I is equal to I plus 1. How much it became what? 9. 9 is less than or equal to 10, true. I print 9. Then I became 10. 10 is less than or equal to 10, true. I print 10. I is equal to I plus 1. 10 plus 1 is what? 11. 11 is less than or equal to 10 is what? False. I come out of the loop. Now, let's assume here right now the initialization was not there. What will happen? The compiler itself will give an error because you are referring the I, it is not. Initialization has to be there. How many times initialization needs to be done? In my structure of the loop is it initialization, then it goes to what? Condition. After condition it goes to what? Statement. After statement it goes to what? Updation. After updation again it come back to what? Condition. If the condition is true, it will execute. If the condition is false, what? It will exit. Got it? Now look at this. If I say here in this case initialization is not there, loop is not going to run. What would happen if I say if my statement is not there? What would happen? It will never print it. What happen if my updation is not there? If my update is not there, what would happen? I is 1. 1 is less than or equal to 10. Print 1. Then again it will go back. 1 is less than or equal to 10. It will print 1 infinite time. Therefore, in every time, remember, you must have an initialization, you must have a condition, you must have a statement, you must have an updation. Okay. What is a condition? The condition will terminate the loop. What is the updation that makes a condition as false? Who makes a condition as false? This guy. If I don't have an I is equal to I plus 1, I will never reach what? 10. If it doesn't reach 10, in 11 it will never what? Come out of the loop. Therefore, the purpose of updation is to make the condition as false. Makes the condition as what? False here. Got it? Yeah. So this is the structure of a loop here. Now, sir, this would have done, we would have done it in a for loop. Yeah, I agree. So whenever your updation is in a sequence, use what? Use a for loop only. This is better option. Your updation is a sequence. If your updation is random, Okay, use a while loop. What do I mean by this statement? Whenever you want to say how many time I need to execute a statement, if you know how many times you know, use a for. If you do not know how many times, when you write a algorithm, when you write a logic, if this question raises to you how long I need to execute a statement, use a while loop. What is the meaning of this? How long? So we talked about how long it needs to be executed. Then I will use what we said it will execute a while loop here. Okay. So what is the meaning of this statement? Okay. Let's see in this cases. I want to right now count the number of digits in a variables. Count the number of digits. Let's say my x is right now 74532. I want to count the number of digits. Okay, you want to count the number of digits, what to do? If you want to count the number of digits, what do you do? Cut one digit. If I say cut one digit, how to cut a digit? If you want to remove the 2, divided by 10, right? But if you say x divided by 10, it won't cut the digit. It will put what? 7453.2 it will become. But divided by 10. How much it became? 7453, which I'm going to store it in x. My x became 7453. Again, if I say divide by 10, 7453 divided by 10 is what? 745. X became 745. Again, I divide by 10. How much it became what? 74. Again, I divide by 10. What will become? X divided by 10. 74 divided by 10 is what? 7. Again, I'm going to divide by 10. 7 divided by 10. How much it became what? 0. Do I need to divide again? No. How long I need to repeat this procedure till my x became 0. Therefore, till my x became 0, I need to repeat this procedure. In this case, how long? In this case, you will write while. How long I need to repeat the procedure? X is not equal to what? 0. As long as x is not equal to 0, what is the procedure I need to repeat? X is equal to what? X by 10. A statement needs to be repeated. But remember, I must know the purpose of this program is to count the number of digits, right? If you want to count the number of digits, what I need to do here? I am going to put a counter. I put C is 0. C is equal to C plus 1. First time I came 74532. C 0 is not equal to 0. Yes, C became 1. Divided by 10. How much it became? My X became 7453. 7453 is not equal to 0. C plus 1 is 2. Divided by 10 is 745. 745 is not equal to 0. C plus 1 is 3. Divided by 10. How much what? 74. 74 is not equal to 0. How much? C plus 1. How much it became? 4. 7. 7 is not equal to 0. How much it became what? 5. 7 divided by 10. How much it became what? 0. I came out. When I come out, I want to print. What I need to print? What? The C. Now in this, what is my initialization? Yeah, this is my initialization. Why? Because that gives an initial value to my condition. This is my updation. Why? Because that makes a condition as false. And then what is this? This is my statement. Here, this is my initialization. This is my condition. This is my statement and updation. That means the initialization, condition and updation must be related with each other. Must be related with what? Each other. And here, this is my statement. Whatever needs to be executed once has to be outside. Printing the number of digits where? Only once outside. Initializing the C to 0 how many times? Only once. Where? Outside. Whenever you want to execute a statement again and again, that should be where? Inside. Otherwise, if you want to execute only once, keep it where? Outside here. Okay. Got it? Yeah. So let us see here in this cases. I want to write this code and see first. So I have a number. Correct? What to do? Why we wrote x is okay, and also can write. Doesn't matter for me. What is it? In order to keep a track of this, I need a counter. What is the condition we said? While x is not equal to 0, I want to say c is equal to c plus 1. No, I need to say x is equal to what? X divided by 10. Print what? C. I run the code. And I got 5. I got the output what? 5 I got. Got it? Yeah, okay. Now let's take an input from the user. I'll take input from the user. Int input, enter a number. I'm going to enter a number. If I say here in this case 5, 6, 7, I got a number of digits is what? 3. Correct? Okay, let's solve another problem. Okay, now before solving a problem, take a notebook and write it and analyze it. Then you write a code. Okay, don't just directly come to write a code here. Okay, now look at this. I want to find out right now the sum of the digits. Let's say my x is right now 8453. I want to find the sum of the digits. What is the sum of the digits? I need to what in this case? I need to say 3 plus 5 plus 4 plus 8. Okay. It's easy to say 3 plus 5 plus 4 plus 8 rather than saying 8 plus. Why? Because if you want to start from here, what we need to do here, you need to know how many digits are there, right? Here, if you can, if it you can take the first digit, cut the digit, then go to the next one, right? You can get into that. Okay. So therefore, what I can do first, I need to find the sum of the digits. First, I need to get the 3. How to get the 3? X mod 10. How much I get? 3. So I'm going to store it in S. Okay. Now what I need to do here? I'm going to say here in this case, I need to cut this digit. How to cut the digit? X is equal to X by 10. It became 845. Now X mod 10, if I say, how much I'm going to get what? 5. Why? Because my X is right now how much what? 845. It became 5, right? 5, I need to add with S because my 3, S is already 3. Therefore, I'm going to say S is equal to what? S plus. Why? Because this is what I mentally do. First I take 3, I remember, then I take 5. 3 plus 5 is 8, then I remember. 8 plus 4 is how much? It is what? 12, I remember. 12 plus 8 is what? 20, I remember, right? Therefore, I'm going to write 4. Now, it became what I took. It became 8. S became 8. Now, I'm going to say X is equal to X by 10. How much it became what? 84. Now what I should do? If I say X is what? I'm going to say here in this case X mod 10. How much I get? 4. 4 needs to be added. Therefore S plus S is equal to what? S plus how much it became what? 12. Correct? Now I'm going to say here in this case X is equal to X by 10. How much it became? It became 8. Now I'm going to say here 12 plus X mod 10. How much I get? 8. 8 mod 10 is what? 8, which I store it in what? S. Therefore, S became 20. X is equal to X by 10. It became 0. How long? I need to repeat a procedure till the X became 0 while X is not equal to 0. What is the procedure? I was repeating S is equal to S plus X mod 10 and X is equal to what? X divided by 10. But sir, what about first time? First time you directly wrote it. Oh, simple thing. What you can do? I can say S is equal to 0. Here, if I say S is equal to 0, I would have said what? S plus, right? That means the same statement got repeated. How long? Till the number became what? 0. That's it. Therefore, how I do? I write a code. The same code I'm going to modify it. So what we did, instead of adding one number, what I did was I need to add what? The remainder every time. X mod 10. X mod 10 will give you one digit. I'm going to say here right now, if I run the code, I'm going to say here right now, 4, 5, 6, 2, 3. How much you should get what? 20. Got it? Yeah? No, sir, I want to find out which is the largest digit. If you want to find out which is the largest digit, what I should do? I am going to say here in this case, X is equal to 74528. Or let's say 747, I put 9. Which is the largest digit? 9. Okay, now what I do? First time I saw 8. Then I remember the 8 so far. Since mentally I work like this. First I remember the 8. Then what I do? Then I saw 2. What I remember so far, which is the largest digit I have seen? 8. 8 I remember. There is a 9. When I see 9, so far what is there in my mind? 8. I change my mind to what? 9. That's what I do. Then 9, I compare what is there in my mind with the next digit. 9 and 4. Who is the greater is what? 9. I keep the 9 as it is. 7. I keep the 9 as it is. Therefore, what I did every time, I compared the next digit with what was there in my mind. If what is there in my mind is greater, I keep as it is. If it is smaller, I change my mind. This is what I did. This is what I did. Okay. So let's go into code. What I did was I took a digit. See, this helps me to find a digit. Let's say C represent my mind. Okay. I take the digit, right? Then what I did, I compared my last time I was adding and storing in my brain. This time what I need to do, I have to compare whoever is greater that I need to store in my mind. What I should do, if C is less than D, If C is less than D, C represents what? C represents my mind. What I should do? I need to put in my brain, I need to put the C is equal to D. Otherwise, what I should do? Keep the C as it is. Keep the mind as it is. So you don't, else you need to say C is equal to C. You don't need to say. Else you have to say C is equal to what? C. No need to say. Let it be as it is. I put enter a number. Remember how long I repeated procedure till the number became what? 0. Therefore, 7, 8, 6, 3, 2, 1. I put like this. This is the largest digit, 8. Okay. What I did? I took a digit, I compared with my brain. My brain is represented by a variable. I did this. Okay. So let's see, let's take one. But remember, every time a loop must have a initialization, condition, statement and updation. What is my initialization here? This is my initialization. This is my condition. How long I repeated the procedure till the number became 0. Which is my updation? This is my updation. And these are my statements. These are my what statements? What is the statement does? It changes my mind when I see a digit which is greater than what is there in my mind. Initially, I initialize my C to what? 0 is, why did I initialize a C to 0? Because C 0 is the minimum digit you can ever encounter. Therefore, I put what? 0 initially. So let's solve another problem. Okay. So let's see in this case, I have been given a number. I want to reverse this number. I want to what? Reverse this number. What is a number is what? I have been given a number. Let's say my x is right now 7453 is a number. I want to reverse this. What I should do? First I get what? 2. Next what I get? 3. So what I should do? Should I add 2 with 3? If I add 2 plus 3 it will become 5. Whereas when I see next time what should become 23 now? Therefore what I need to do? I am going to multiply the 2 with 10, add. It will become 23. Now what is there in my mind right now? 23. 23 into 10 plus 5. How much will become? 235. Next time what? 235 into 10 plus 4. How much will become? 2354. Correct? 2354 into 10 plus 7. How much it became? 23547. Do I need to do again? No. My number became 0. Therefore what I did? Okay, then what about first time? Simple. Whatever is there in your brain, multiply by 10, add the digit. 0 into 10 plus 2 is what? 2. That's it. Next time 2 into 10 is 20 plus 3 is 23. So what you should do? Take a digit, multiply what is there in your brain with what? By 10 and add the new digit. Repeat the procedure. How long? Till the number became 0. Okay. Let's write a code. So what we did was took a digit. Yes. Then what we did? What is there in my brain? C is there in my brain right now. C represents my brain. Multiply with 10. Add the new digit and store it in what? In my brain again. C represents my brain. How long I need to repeat the procedure till the number became 0? That's it. To one digit and cut it. So let's say in this case I have 1, 2, 3, 4. It should become 4, 3, 2, 1. If I enter right now 7, 0, 0, 2, what should become? 2007. Now you are going to have a problem. What is the problem? If I enter 2700, it will give what? 72. Why? Because we can't put a 00 before. Not possible. Therefore 0 into 10 will become 0. 0 into 10 will become 0 only. Therefore the first 2 iteration, it will go only get zeros only, you will get it for you. Okay. Let's go to the next one. I have right now, what is it I have right now is this what I have. I have 2 numbers right now. Let's say x and y. My x is right now 175. Y is right now 125. I want to find the greatest common divisor. If you want to find the greatest common divisor, what I should do? I am supposed to what in these places? I need to what? I am going to apply an algorithm. What does algorithm says? Subtract the smaller one from the larger one. Store the result in the large. 175 minus 125, how much what? 50. Who is the greater now? This. 125 minus 50, how much what? 75. Subtract the smaller from the larger. Store the result in larger. 75 minus 50, how much what? 25. 50 minus 25, how much what? 25. If both are equal, That is a GCD. If both are equal, that is a GCD. That means how long I need to repeat the procedure till both are equal. Sorry, till both are what? Equal. Therefore, as long as they are not equal, what I should do? Subtract the smaller from the larger. This is a statement needs to be repeated. Subtract the larger. If x is greater than y, say x is equal to x minus y. Otherwise, say y is equal to what? Y minus x. Repeat till both are equal, right? When both are equal is going to come out. So what is my initialization? Yes, this is my initialization. This is my condition. Here my statement and updation is in single. It is there. Therefore, it is a single. It is there. It's both are together. It is there. If x is greater than y, subtract x is equal to x minus y. Otherwise, y is equal to y minus x. Repeat the procedure how long? Till the both are equal. Got it? Yeah. Therefore, remember, so whenever you write a while loop, when I should write a while loop is whenever the question of how long I need to repeat a procedure, use a while loop. The next is when you write a while loop, remember you should every time need to check there must be initialization, there must be a condition, there must be a statement, there must be an updation. What is the updation? That makes a condition as false. That makes a condition as what? False. Whatever you want to do once has to be outside. Whatever you want to do many times needs to be where? Inside the loop. Got it? Yeah. Let's solve one more problem. I want to write now in these cases I have been given two numbers. Okay. This is a good example for how to use a while loop. I have been given two numbers 19 and 10. I want to find the product of 19 into 10. 19 into 10 is how much? What? 190. How I want to get the 190? Simple logic here. Divide the first number by 2 and store it in the first number. 19 divided by 2, how much? What? 9. I am taking only the integer part. I am not taking the fractional. Multiply the second number and store it in y. Divide by 2, multiply by 2. Divide by 2, multiply by 2. Divide by 2, multiply by 2. Divide by 2, 0. How long? I need to repeat till the number became 0. Now, while you are doing this procedure, if the x value is odd, add the y values. 160 plus 20 plus 10, how much? What? 190. 1 what? 90. 160 plus 20 plus 10 is what? 190. How long will you repeat? Till the number became 0. That's it. Which number became 0? X became 0. Therefore, I am going to write here in this place is while x is not equal to 0. What is the procedure I repeated? Before I divide the x by 2 and multiply the y by 2, what I did, I checked whether the x is odd or even. If the x is odd, how do you know x is odd? If x modulus 2 is not equal to 0, x modulus 2 is not equal to 0. If what I did is I added the y value in my brain. This is 0. Then what I did, I divided the x by 2 and multiply the y by 2. At 10, I printed the s. Okay, got it? Confident? Can I lock it? Yeah. Okay. So always remember, first understand the problem, then see what is my initialization, what is my condition, what is my statement, what is my updation. Updation must be there at the end before you go for the next iteration. Got it? Yeah. Good. Okay, let us solve another problem. Okay, I want to find the prime factors of a number. Okay, let's say in this case I want to find the prime factors for 36. What are the prime factors? Okay, let me see how do we find this. Okay, if I ask you to find it, how do you find? First is you will divide this by 2. 36 divided by 2, how much it is? What? 18. That means it's dividing. Correct now? That means 2 is one of the this. Then again you will try to divide by 2 only. Yeah, it's dividing. 9. Therefore, another prime factor is what? 2. Then again you will divide by 2. Can I divide it? No. Divided by 3. Yeah, 3 is a 3 is another prime factor. Again divided by 3. Yeah, 1 and 3. Now you can't, you won't go ahead because 1, right now. Therefore, the prime factors of 36 are 2, 2, 3 and 3. Let's say in these cases I want to find the prime factors of 60. What will do? I will divide by 2. 30 and 2, right? 2 is dividing. Then again I will divide by 30. 15 and 2. Then again I'll divide by 2 again. 2 won't divide, right? Then if it's not dividing, I'll try for 3. Yeah, 5, 3. Then I'll divide by again 3. 3 is not dividing. Why? 5 divided by 3 is remainder is not dividing. Therefore, what I'll do? Again, I will do what? 4. Can I divide by 4? 4 is a prime number. Don't worry. Try with 4. Why? Because you extracted all the 2's out. Therefore, 4, even if you try, nothing will happen. 4 is not a prime. Anyway, you've taken out all the 2's. Therefore, I'm trying with 4. Yeah, 4 is not dividing. Correct now? 4 is not dividing. Then I'll do it for 5. Is 5 is dividing? Yes. 1 and 5. So how long I need to repeat the procedure till the number becomes 1? Okay. So how do I write it? Till the number becomes 1. Therefore, what I will write? While number is not equal to what? 1. As long as the number is not 1, do. What you were doing, first time tried with 2, then again tried with 2. If it is not dividing, tried with what? 3, right? Therefore, you need to keep on increasing. Therefore, I is 2. If n mod I is equal to 0 means what is the meaning of this? Is dividing, right? Then I can print the I. After printing the I, what did you do? You divided the number by 2. Therefore, the number became n is equal to n divided by I. Then continued it. Now, if it is not dividing, what did you do? You went to the next number. I is equal to what? I plus 1. That's what it did. How long repeated? Till the number becomes 1. Okay, so let's write the code and see. I took a number. First time, how long you divided the number? You started with 2. How long you went? Till the number becomes 1, right? Till becomes 0. What you did first is, you checked if x mod I is equal to 0 or not. If it is 0, what you did? Yeah, it is dividing. Correct now. If it dividing, you said print. I put what? I. And then you said x is equal to x divided by. Otherwise, what you did? X is equal to x divided by I. If not, what did you do? You increase I by 1. Else, you write I is equal to what? I plus 1. That's it. And I don't need to do. Is that there? Let's say what I need to do here in this case is I'm going to run the code. I'm going to enter the number. My enter number is what? 18. I put my prime factor 2 and what? Right? If I enter right now, run again. I enter right now, say 60. The prime factors are what? 2, 2, 3 and what? 5. Okay. Now, the while loop in Python, you can also use else for while loop. Okay, so the while loop else it is. I can say print. Yeah. When you will come to the else part is if this condition fails, then only you'll come to the else part. If the condition does not fail, you will not come to the else part. Okay. Now I'm not going to make and show you also. Okay. Let's say print and put all this. So I said that whenever the condition becomes false, then only you'll come here. Okay. Let's say in this case, I want to write a program to say whether the number has only itself has to be what? The divisor. 1 and itself has to be the divisor. No other divisor it can have. Okay. No other divisor it can have. In this case, how do I do this? No other divisor. That's a prime number, right? Now, no other divisor it can have. So in this case, if anybody divides, I don't need to continue. Correct? I don't need to what? Continue this. Break. If you break means you don't come to the else part, otherwise it will come. Okay, let's see in this case is, yes, in this case, before breaking, I'm going to say print. X is not a prime, sorry. Anybody divides, it is not a prime. Otherwise, I'm going to say X is prime. Done. I'm going to run the code. I entered right now 25. not a prime, right? If I say right now, so if it say, I'm going to say right now in this case is, let's say 11, it is a not a prime. 11 is not a prime? Oh, I'm very sorry. Till what? Till the number divisor. Sorry. Till the I becomes a number right now. So we are not dividing. I'm very sorry. X is what? I is less than what? X. Hmm? The number is what? 11. The prime. So it will come to the else only if the condition becomes false. Okay. Say 25. Okay. Yeah, just for you to have. While also can have a else, it will come to the else only when the condition becomes false while. Okay, if you break in between, it won't come to the else part. That's it.